Good morning, everyone. Today we're going to be doing the notes for permutations and combinations. And so the difference, this will be on page 29 in our ISN. The first important thing we need to know is what is the difference. So a permutation is a set of objects in which the order is important. Okay, so the order does matter. To a permutation, the trio of Brittany, Alan, and Greg is not the same as Greg, Brittany, and Alan, because permutations are picky, and so the order that I want things does matter. Whereas in a combination is a set of objects in which order is not important. So to a combination, the trio, Brittany, Alan, and Greg, is the same as Greg, Brittany, and Alan. Okay? As long as I have a combination of them, I just need one. Okay? So let's look at how to tell the difference between a permutation versus a combination. Okay? So permutation is on this side, and combination is on this side. So look at the difference between number one, picking a team captain, pitcher, and shortstop from a group, versus a combination is just picking 3 team members from a group. That's a difference between a permutation and a combination. Picking your favorite 2 colors in order from a color brochure. So your first favorite color and then your second favorite color, versus just picking 2 colors from a color brochure. Another difference, picking first, second, and third place winners, and then versus saying just 3 winners. 3 people win. That is not the same as first, second, and third place. Okay, so there are some formulas. A permutation is a set of n number of things taken r at a time without replacement, and where order does matter. So these are the 2 variables you're going to see in the formula, an n and an r. And so this is the format. We use an n, it's like a subscript, and then it's capital P, and then r is a subscript. That equals the n amount factorial over parentheses n minus r, close parentheses, and then factorial. Some special cases are labeled here. Those are just good to remember. When r is 0, it's equal to 1. When r is 1, it's equal to the n number. And when these are both equal, this just equals n factorial. So keep a lookout for those special cases. Okay, for a combination, the set of n things taken r at a time without replacement, and where order does not matter. So very similar, but this time the order does not matter. Okay, and the formula is a slight bit different. So here's n p r equals n factorial over r factorial parentheses n minus r factorial. Okay, and what is the difference between n and r? N is the total. Let's just write that down. N equals the total, and r is the number of that I want. Okay, so what I'm looking for. And then here's another set of special cases for combinations. If the r is 0 and equals the n, then that equals 1. If r is 1, then this is n minus 1. That equals just n. And then we have here n r special cases. All right, let's go to the next page. Does order matter? Question to determine combination or permutation. So number 1, does order matter? Well, for combinations, no. For permutations, yes. Okay. How many objects do I have? That's the N. How many objects are being taken at a time? That's the R. Okay, so example 1. Choosing 5 students from a class to work in a special project. I'm choosing 5 students for a special project, so the order doesn't matter. It's just put them in groups of 5. So that's a combination. Arranging 5 slides in a PowerPoint presentation. This is the keyword that I always look for, arranging. So in a PowerPoint presentation, the order of your slides does matter, so that's a permutation. Being dealt a hand of 5 cards from a 52 deck of cards. Well, if they're just handing them to me, the order doesn't matter, it's just a combination. Ooh, D, arranging the letters in the word algebra. Yes, we have to spell algebra correctly, so that's a permutation. Checking out 3 library books from a list of 8 books. Does the order matter there? If you're just checking out 3 books from 8, not really. The order does not matter. Okay. All right, here's example number 2. The manager of a baseball team has to select 9 starters for a game. She has 11 players to choose from. How many combinations of 9 players can she choose? Okay, so keyword combinations, they already told us it's a combination. So N is the total. How many are there to choose from? 11. R is the number that I want. I want 9 starters, so R is 9. And so let's write our formula. Remember, N combination R equals N factorial over R factorial N minus R factorial. Okay, so we plug all those numbers in. That's 11, C, 9 equals my N factorial, L factorial, 11 factorial, 9 factorial, parentheses, 11 minus 9 factorial. Okay, so let's just simplify this. 11 minus 9, that's going to change to 2 factorial. And here at the top, I'm just going to erase really quick because I want to just cancel that 9 factorial right away. And if you were here yesterday, you remember that when we count down and we see that similar factorial at top and bottom, we can cancel those. Okay. So then I'm left with 11 times 10, which is 110, over 2 times 1, which is just 2. So half of 11 and 10 equals 55 combinations. Okay. All right. Let's continue to a permutation. Okay. The manager of a baseball team has named the 9 starters for a game. She needs to determine the batting order. How many batting orders are possible? So now that we have the 9 players, there is 9 orders for the baseball team, so the total is 9, and I have 9 players to arrange in the batting order. So this is a permutation. Definitely the order matters. If you play baseball, you know that that order does matter. So NPR equals N factorial over N minus R factorial. Okay? All right, let's see what we have here. So if we plug everything in, we have N equals N factorial over 9 minus 9 factorial. And this is actually a special case like we saw in the front where the N is equal, and so for permutations, when that happens, you just end up with the N factorial, and that's what's going to happen because 9 minus 9 is 0, and so I'm left with 9 factorial over 0 factorial. And yesterday we learned 0 factorial equals 1, and so there's nothing happening there. Okay, so then we just multiply the 9 factorial. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is a total of 362,000, that's a 2. 1,880 orders. This is a 0, by the way, that's an 8. Okay. All right. Okay, I want you to try, actually, let's skip number 4 over here. On this side. We can skip this one. I want you to try example 5 and example 6. And pause the video so that when you finish, you can check your answers, okay? All right, I'm going to pause it, and then you can work on 5 and 6, and then come check to see if you did it correctly. So press pause. Press pause. All right, so if you finish the pizza combo pizza, 5 toppings from a list of 16 toppings, how many different combo pizzas are possible? Here is the answer. So n equals 16 because that's the total number of toppings. R equals 5 because that's the toppings that I have to pick. And so when you plug everything in, we have 16 combination 5. And yes, this is a combination because the order of the toppings that I choose does not matter. They're just going on the pizza. And so if you did permutation, please go back and erase that and put a combination. So 16 factorial over 5 factorial, and then 16 minus 5 inside the parentheses simplifies to 16 factorial over 5 factorial times 11 factorial, and then we expand that, and I can cancel the 11 factorial that I knew was there on the bottom of the denominator. And so then after all that, we expand the 5 factorial, and that equals 4,368 combo pizzas. So if you did that correctly, good job to you. Example 6 is a little different, and so I wanted to pause because you have to do 2 combinations. So you have to do the combination of boys first, like separately, and then combination of girls, okay? And so it's not the same because they had a restriction where the team has to be 1 girl and 2 boys. And so for boys, the total is 12, and the number I want is 2 boys. And for girls, the total number of girls is 14, and the number I want is 1. And so you have to calculate this separately first, and then after you get your totals, then you multiply it. And so for here, it was 12 combo of 2, which is equal to 12 factorial over 2 factorial and 10 factorial. And that simplifies to 66. And then for the girls, we have 14C1, which equals 14 factorial over 1 factorial and 13 factorial. And so those will cancel and give you a total of 14 after you expand that. And so then we have to multiply 66 times 14 to get that combination total, which equals to 924 ways that we could select for our 1 girl and 2 boys. Okay? All right, please glue this on page 29 in our notes, and now it's time for practice. Make sure you show your work. Bye.